The mean value theorem for definite integral states that if f of x is continuous on the closed interval ab, then there exists at least one number c in open interval ab such that the integral of f of x dx from a to b is equal to f of c into b minus a. F of x is continuous. We will try to prove it now. Since f of x is continuous, as claimed in the theorem, then by the extreme value theorem, f of x attains a maximum value capital M on the interval AB, and also a minimum value small m on the same interval AB. What does that imply? That implies that for all x elements of AB, the minimum value will be less than or equal to f of x, and that is less than or equal to the maximum value. Integrating this over the interval AB, what do we have when we integrate over the interval AB? Let's see. When we integrate over the interval AB, what do we have? Integrating over the interval AB, we have the integral of small m dx from a to b to be less than or equal to the integral of f of x dx from a to b, and that is less than or equal to the integral of capital M dx. Remember the properties of integration, or the properties of definite integral. We have that dx to be less than or equal to the integral of f of x dx from a to b, and that is less than or equal to capital M integral of a to b dx. This gives us what? N into b minus a. Remember again another property of definite integral, to be equal to a to b f of x dx, and this is less than or equal to what? Capital M into b minus a. Our a is less than b. By the time we divide through by b minus a, divide through by b minus a, we have m to be less than or equal to 1 over b minus a into the integral of what? F of x dx from a to b, and that is less than or equal to our capital M. Now at this point, we need to make use of another theorem, and that is what we call the intermediate value theorem. The intermediate value theorem. How does that come into play here? The intermediate value theorem. By the intermediate value theorem, there exists a C, or better yet, there exists C element of AB such that f of C will now equal to that. Will equal to 1 over B minus A into f of x dx from A to B. We have f of C into B minus A to be equal to the integral of f of x dx from A to B. That tells us that if f of x is continuous, which is where we started from, as stated in the mean value theorem, if f of x is continuous, then there exists a C on the interval AB such that the integral of f of x dx from A to B is equal to f of C into B minus A. That is the proof. That is the proof of the mean value theorem. You can try your hands by trying to prove this theorem also, and then in subsequent videos we will see how to apply the mean value theorems in solving questions on Riemann